Right now, at the end of our break, another one of our vendors is here, Teledyne API, Doug Haugen. Doug actually is local. He lives up in Fort Collins, I think. Did I get there? Are you in Fort Collins?
Yeah.
Okay. So he lives in Fort Collins, Colorado, which is where Colorado State University is, and it's about an hour and, well, depending upon traffic, an hour and 10 minutes to 2 hours and 30 minutes north of Denver, depending upon the traffic going north out of there. But Doug's from Teledyne API, and you can take it away. You got to keep inside the square.
All right.
All right.
Good morning. As Walt said, my name is Doug Haugen. I've been with Teledyne for an embarrassing length of time. I intended to come into the monitoring industry and learn some things, have some fun, and then go do another job. And it's 29 years later, and I'm still doing this. And the reason is, in large part, because we work with very cool people that have a more than passing interest in doing a good job. I work with really smart folks, both on the user end. The customers are very highly educated. They're pretty demanding. You guys should take that as a compliment. We're expected to make stuff that runs. That's why when Walt introduced Ray as the guy before me, I was like, oh shit. He's gonna bust my chops on all kind of analyzer stuff, and then I have to follow that. But I've worked with CiSCO for a number of years. Yes, I do base in Fort Collins. It's simply because I want to. In earlier years, I was out at our plant in San Diego. The facility we have out there, Teledyne is a really large company, on order of about $5 billion company. They've got a lot of individual business units. They bought us back in 2001. Teledyne API is about a 30-year-old company. And our management group has stayed intact throughout that in large part. I report to one guy, Martin Abbott, that's the general manager. We've worked together for 16 years. That's long enough to get on each other's nerves, but also to get a good comfort level for what we do as a company working with you. And with CiSCO, it's like the relationship we have with a lot of our end users as well as integrators, where we probably learn more from them than they get from us. An example, he talked about, just in passing, we had detector issues, which was a rarity for us. We always have issues, don't get me wrong. That's part of building analyzers. Pete could attest to it. So I'll never throw rocks at a competitor if I'm thinking clearly, because I realize how hard it is to reliably build instruments that are going to last you 12 to 15 years in the field. We had some components, our detectors for our IR boxes that had historically been life of instrument components. Well, they started failing in the field, and they failed in the most painful aspect for all of us, where they made it through vendor testing and burn-in. They made it through our testing at the plant and burn-in and instrument test, got out to an integrator, got through their system tests and FAT, went out to the field, and then failed after some weeks or months of use. Well, CiSCO was one of the first repositories for that information to me. And you may recall that I was in your lab when you guys also discovered that one of our first replacement detectors had a wavelength issue. We were sitting there, and for some unknown reason, they were running CO2 through the instrument. And they said, Doug, look at this, it's deflecting. I'm like, what the hell are they talking about? You know, Ray's full of shit again. And nope, it was deflecting. And so we had really early insight, far before we picked up on it, that vendor working with an alternate component had missed on the filtering, and it would have caused a lot of intermittent issues had it ever gotten out to the field. So that's one of the things that's definitely kept me in this industry. It is definitely a quid pro quo relationship. If we make a mess, we hear about it forever. I think the ice age lasted a little while. It's way faster than the rate of adoption in the CEMS world. You know, I ran into Bart Gossett recently, who works with Teledyne these days, but first thing he said was he harkened back to 16 years ago when he needed a spare part. And fortunately, I was willing to go over to the plant in San Diego and FedEx him one. That's what he remembers. He does not remember my middle name. He doesn't remember that we worked together, but he remembers 15 years ago when he needed a spare. So what I'll go through is basically what we sell now, our new generation instrument. Hop in if you have any questions as we go through. One thing I should talk about on the front end, since Walt mentioned it, supply chain issues. That has caused us connection fits on some product lines on our T series, which is still our primary product line for your business. We've been relatively unfazed. And I say that with exceptions for sure, because we get some odd shortages. Like, for example, logo shirts. I had a conference last month, ordered a bunch of logo shirts for my crew. And our marketing coordinator got back to me and said, we can't get those. I'm like, well, what the hell are you talking about? That's like error to a corporation, right? Logo shirts. Nope, we can't get them. It's 6-month lead. So we get weird things like that, but we've been fortunate, not so much through planning, but our Asian content for our instruments is virtually nil, which startled me. Even a couple of years ago, I had a competitive situation where it was in Chile, and they asked to see our current sourcing on where our components come from. I thought we'd have a pretty healthy offshore component level. Very little. And all it means is in the near term, that causes us less heartburn with the T series. With the N series, which I'll be talking to you about as our newest generation, we've had more issues because we use newer generation ICs. And those we compete with the auto world. And so that was something where they've definitely been trying to ramp up production in that. And when you're competing against usage of that magnitude, it's tough to compete. So on that and on some of our industrial ozone lines, which you all may not be aware of, but we build quite a few instruments, those have definitely caused some lead time issues. We stay pretty focused as far as what we build. What we term ambient analyzers is the criteria pollutant style analyzers the US EPA and a multitude of agencies around the world use. Source level is your industry, and I'll get into that a bit. The things that we're most widespread on are things not so much relevant to your world that are very relevant to US EPA and the monitoring agencies. So when you hear about the ambient folks, rather than using simply cylinder gases, they use cylinder gases and dilute to various levels for calibrations with zero error generators. They use calibrators to control those dilution levels. So instead of having 6 cylinders on the wall, they'll have 1 cylinder for that gas of interest and use a calibrator along with a zero error generator to produce custom gases at various concentrations. We do continuous particulate monitors. So in Colorado right now, if you hear about the ozone, the CO, the particulate, if there's a problem, you can blame me. It's our gear, which is great. But it's like when it's happening out at your plant, that's, for you all, it's like, how could this happen? Teledyne's not doing their job. For us, it's unfortunately Tuesday. And we have to figure out what's going on and move on with it. So what we do in that regard is we've got pretty extensive technical support. And over the years, that's how we spend our marketing money. Yes, I have a nifty logo shirt, but that's about the extent of what money we spend on marketing. We've run our tech support group not as a profit center over the years, so we can work with folks like CiSCO and with the technicians you have on your site, hopefully for the things that haven't come up before, like Ray was talking about the memory aspect. That's something that has cropped up that you wouldn't see on the front end when you're coding for a new firmware set. It has to do with the internal memory usage, and it builds up over time. And how it will be addressed moving forward is with firmware updates, where we no longer have that memory usage. First place we saw it with the NumaView, which is our current interface, was with a particulate monitor. The reason we saw it there first is we had some that were out for 8 or 9 years. So it takes a number of years before something like that shows up, and how we'll address it moving forward is with updated firmware. We do in-house repairs, but again, it's usually where there's a warranty or something that Ray and his crew don't want to deal with or haven't seen before. It's as an adjunct. What we really prefer is to do this last one, where we've got training capabilities. During the virus, we were really lucky that way, in that we would have been shut down absolutely if we weren't just ready to roll into doing a lot of remote training interface. So for the last 2.5 years, we've done literally hundreds of trainings. I still cover Latin America, and it's really nice to be able to do a multi-camera setup with displays for the individual instrument interfaces. So if that's something that you would like to work with CiSCO on, to have us add some specific focus on a topic, we can do that. That's helped us a ton. But what we prefer to do is impart the training to the field, so you all can take care of your instruments and, again, feed us back with what we're not doing well. Oh, I wanted to make mention, it's not just to have a good looking guy up there. That's one of the key yard marks for me in this. That was us delivering our 100,000th instrument, which for a relatively small company is a huge deal. And that's a few years ago now. We're up about 110,000. I wanted to point that out to you because this is our day job. Building basically 19-inch rack mount analyzers is what we do. And we're pretty tickled that a company our size can do that. Teledyne's huge. I didn't tell you, we're about 150 people at a single building in San Diego. I was out there for a couple of years, but I escaped back in the field so I don't have to go to meetings. I recommend that highly to any of you. I mentioned the ambient gas analyzers. We do business everywhere in the world we're allowed to. There's about 4 countries that rotate based on current events that we can't sell to. Everywhere else in the world, we're active. Overseas, we mostly work with distributors. I've got counterparts in Europe and China, but primarily we like to have people in the markets that are technically proficient and, again, trained on our gear. Some things we don't do for you all: chemiluminescent with moly, that we do, or with a stainless steel, that we do. We also do some pretty exotic instruments that really haven't gotten adoption for the CEMS world as yet. But in the ambient world, in the research world, there's definitely cutting edge stuff that we need to do well. So this one, photolytic converter, some of you may have heard of it. You may have heard about it from the bright boys up at GASL in Canada. They're at a lot of the conferences. It's where, instead of a moly or a stainless converter doing a catalytic conversion of NO2 so that the chemi can see it, you're using a blue LED converter. And we actually have the intellectual property on that. Guy over in Golden by the name of Marty Burr designed it with NOAA. That's the kind of thing that we work with that gives us more insight into why a traditional chemi that you're using with a moly may not be behaving well. It's a more selective conversion. You don't have as many positive interferences as possible that you get with a conventional catalytic converter. Another one that you may or may not have heard of is cavity attenuated phase shift. That's getting big play with the ambient monitoring. State of Colorado uses CAPS, as it's called. It only sees NO2. So it's the reverse of a chemi where you're only seeing NO and you have to convert NO2 to equally see it. Well, CAPS is NO2 specific. So it gives a more selective view. You probably all realize that all things being equal, chemistry is not the most elegant method in the world, but it's the method we know. And all of us have used it for 4 decades. So we're delighted to continue building those, but it's useful to have these other technologies. It informs us on how well our chemies are performing. Our other instruments aren't certified in place like your systems are, and they are type certified. So if we build an ozone instrument, for example, it has to be submitted to the EPA. They give it its blessing. It has to have extensive field testing. Every instrument we build then that goes out like that is certified. In your world, we don't have certifications as such other than the quality ones like CE or CSA, and they get certified in place. So this is a different market in a lot of ways. What we do is about 50-50 between CEMS and ambient. That varies over the year, varies over market. Like right now in the US, some of the infrastructure monies are being spent to upgrade more monitoring sites. So you'll maybe hear about more activity with that. In your world, it's the normal suspects. We're building the T series and the N series. I'll show you the N series in a moment. The T series is our 4th generation of analyzers. And what we always attempt to do is roll out our next generation earlier than midway through the first generation's life, because it takes years for us to really determine what we want to do as far as the next update. And then we want to have overabundance of transition time, because like when we came out from, you mentioned our legacy software. With our T series, we rolled it out with the legacy, which was basically our old DOS interface that was ported over to Windows operating. And it was a great call, because you know that firmware can have a lot of issues that don't get fully wrung out till everyone's using it in the field and finds out what we screwed up. So the T series, we rolled out as a dual boot, which meant it had the original legacy firmware and then the NumaView that we'll be talking about. In the N series, it was funny because we were talking about what do we name this next product line, you know? And someone, if you can imagine, suggested C series, which cracked me up. It's like, that's been used by our primary competitor. Let's not do that for our new generation. N series, not that you'll probably wonder, but it stands for NumaView. So both are currently available. We do all of the common gases. I'll go through more specific. So UV fluorescence, chemiluminescence with moly or stainless, infrared using gas filter correlation wheels, and then the paramagnetic is the aforementioned Servomex. I was the product manager when we decided that a add-in O2 sensor would be really useful, and a standalone O2 for people that really wanted that form factor. And in looking at the sensors out there, there made no sense to us in developing our own O2 sensor. The Servomex, my opinion, is it's exceptionally robust, and even with their change recently in models, we're not affected on being able to offer the O2 sensor we've used for, I think, 14 years. And over the years, I've replaced virtually none of them under warranty. If you don't booger them up with water or contaminant, yeah. If that doesn't happen, those things are pretty much just going to run. It's hard to imagine, because I used to query my guys, you know, I used to manage the tech support group, and I said, really? Nothing goes wrong? And they're like, nothing goes wrong. Nothing to work on? Nothing to work on. Okay. And pretty much holds true. So we do primarily mid and high level versions, and the dual range is, you know, still operative for the 4 to 20s that most folks use in the field, getting to be a non-issue with the digital. So here's the N series. And there's some key differences. When we do new generations of instruments, we tend to not want to screw around with the analytical hardware. If a bench works well, it usually works well for a reason. That's well proven. So we're very hesitant to change things like GFC wheels or mirrors or sources. So if we've got analytical hardware that's working well, there's not really much reason to update it unless there's obsolescence concerns. So what we focus on is the electronics, first, second, and third. And when we went to the T series, we went from a old style button and narrow display to a touch screen. That was our big concern. We thought that could be a real nightmare for reliability. Well, turns out that was the opposite of what happened. The touch screen right from the get-go is far more reliable than our buttons and displays had ever been. And it got rid of one of the single bigger reliability issues as an instrument ages. Doesn't mean they've been completely trouble-free, but darn close. So what do we focus on with this one? The hardware modules carry microcontrollers on them now. You know, you guys were talking about the demise of the analog potentiometers. Well, we still secrete a couple of pots inside of our analyzers, but there's darn few. Almost all are from the front panel or they're self-controlled. The hardware modules on this, it means that now you've got a flow board. It actually knows it's a flow board, and when you plug it into the instrument, it gets a handshake. We use CAN bus for the internal communications, and I'll show you why in a moment. But what that does is it establishes a handshake between the main board and that smart module. So it says, yeah, I'm a flow module. I'm in a T100H or N100H, excuse me, old habits. N100H gets a handshake to the point that as I show you the wiring, you can plug it into the wrong port on that main board and it won't matter because it's recognizing. So we don't have to have unique ports. And it's great for Haugen, me, working on instruments because I can jack it up and it'll still run. So the other big change is the internal power. We focused a lot of that energy over the years on reducing power components. This helps a lot with analyzer technology because you avoid a lot of the temperature management inside the chassis that can be noisy, that can cause fatigue over time. So we've gone to a completely DC internal power structure. Then this one is one of the few external big changes. We've gone to a fold down rear panel that's split. We've always had that fold down front panel. In large part, that was for the ambient users, so they could open it and look at a 47mm filter. That's what they look at most commonly as a maintenance item. It will continue to use the NumaView, which is excellent from our side of things, because now we've had, for some users, 7 to 9 years of use in the field. With a lot of the gas analyzer users, especially in the CEMS world, less of a time because they were slow moving from the legacy, which I completely understand. You know, people want to use what they're familiar with, not necessarily what's latest and greatest. And then we've revised how we do our flow. We've always used a critical orifice approach where we're running the pumps flat out. Now we're using duty cycle control on a lot of our instruments. We're ramping a pump up and down, which is probably going to help a lot with pump life. So here's what it looks like. Again, standard 19-inch chassis. Anywhere you've had a T-series, this will plug right in. We have significantly changed the back panel. I'll show you the internal structure in a minute, but you'll note on the back, there's a hard power switch. And then on the front, this is the first time we've built an instrument with a soft power switch. That's analogous to what your computer does. And this is kind of a nit, but for those of you that have managed technicians or work on these things, our analyzers have always just had a hard power interrupt. It's no different when you turn the switch than if you pulled it from the wall. And that can cause problems and reliability issues over the lifetime of an instrument, kind of like with ESD damage. And you don't usually see something occur in dramatic fashion, but over time it can cause a failure. So this is the first instrument that has an ordered shutdown. So when you power on that back switch that I just showed you here, it'll go into standby. It'll have a glowing front panel. You push that and it boots and goes through its startup sequence. Same thing when you power it down, it'll go down into standby. And one of the things we forgot on the earliest N series is real life has power interruptions. So you can't have an analyzer losing power and then coming back and not coming back to standard monitoring. So that was one of the first recognitions that it's good to hear from the field. Well, you may remember that that was one of the few significant component changes we made. We went from a first gen touchscreen to a next gen that we've used to current times. That was why they had more of a susceptibility to real life power fluctuations. So good question. The other thing that's significantly different if you've been using a T series is that with the T series, we had all of the I/O capabilities as it shipped. And the only thing you had to identify is how many of the 4-20s you want. So if you had a Knox box with dual range and O2 on board, you'd specify you wanted 3 4-20s shipped with the instrument. Well, now we have the Ethernet and serial standard with Modbus protocol, and then we use an expansion card for the analog output. A little bit cleaner, you don't have to specify what you want. No one's asked us yet, but pricing is going to be very similar for the two. We just go about it a bit differently in that the N series doesn't have a standard internal filter, which is for the ambient world primarily. And so we're able to pare a little bit of expense out of the base, and you have to populate a bit differently for the analog I/O that most of you will use. But very close price from one to the other. Yeah. No, it's almost seamless. About the only changes we've had is we've added a few Modbus register items as we've learned what people are using. And bear in mind that for a lot of these things, we used to wear more hats. So right now, I just am the national sales manager, but we used to be product managers for stuff too. So a lot of stuff on the T series or E series, you could blame me for if we didn't get it right out of the gate. Well, with Modbus, I was sure that you all would adopt it first, because the ambient folks use serial RS-232. And I thought, well, in the industry folks, man, they like robust stuff. They know Modbus. They're going to want that first. So I earmarked all those first for the firmware updates. No, it was the absolute opposite. The ambient folks have gone fully digital over the last 15 years. And we're primarily still building 4-20s for you all, which is great. But it's just an example of why we always have to ask you what you need rather than us coming up with our best estimate. Okay, here's why we really wanted to change the internals. This is how our T series tends to be. We've got 2 power supplies with a relay board, and then we've got a very unique wiring harness with tons of wires running into that chassis. Every time you have wires, you've got crimps, right? You've got terminations, you've got connectors. Those are some of the biggest reliability issues over the life of an analyzer because your folks are taking stuff apart, trying to work around stuff. It was something that we definitely wanted to clean up if we could with next gen. So here's what we're able to do with the CAN bus. Remember that there's more smart modules. So there's a microcontroller on each one of these systems. The ozone generation module, that's the ozone brick in a chemi. You know, and instead of just being a ozone tower kicking out high level ozone, it's got some smarts to it now. And so we're able to use a single methodology. We've dropped to a single power supply. Anytime you can lose an entire component from a design, it's probably a good thing for long-term reliability. And these wire bundles, they're different lengths. But like I said, they've got all the same connector to the main board. You can mix up how they go back together and it doesn't cause any problems. Here's that main board. It's now on the side of the chassis. Here are the connectors. They're all identical. So you could pull this one out, plug it here, pull this one out, plug it down here. The instrument, when you reapply power, will establish a handshake. It'll know it's talking to the flow module as an example. But what's really happening there is it massively cleans up the internals and allows us to drop a power supply. Here are the instruments that we've introduced. So all of the usual components. The only one missing from this is the 800 series, which if you're not familiar is our O2 or O2/CO2. Again, that's that Servomex bench. We'll get there. It's just, you know, lower volume than these other models. Here's an overhead view of our Chemi 200M, and you can see this is a pretty empty chassis, which is, from my standpoint, great. The PMT assembly is virtually identical to what we used in T-Series. It has a significantly revised sensor module. This is if you did have that optional O2 sensor add-in. So this is a full-on 2-gas NOx box. Here's the moly or stainless converter assembly. And from the top, here's that main board. This one is fully featured with both an analog and a digital I/O option. Then you got a whole lot of space to work in. This is your ozone tower up at the front. Yeah. Funny you should ask, because this slide has it on. You can set it up the way you want, but for many years, it was kind of a nice thing about it. I always liked it, but it was one of the things we asked integrators about on the front end. If y'all aren't familiar, behind the front panel of almost every instrument we've ever built, there was a really nice 47mm filter holder. It was turned aluminum with nicely gnarled band on it and a glass face. So those things are very spendy to build. They've got a pretty high cost component. It was a nice fail-safe for you all that have one of Bob's sample conditioner systems upside, but it was just that, a fail-safe. If you looked in there and saw that filter, that 47mm Teflon filter that we shipped to you, you saw bad news on there. In this day and age, that's a fairly rare occurrence. I think I've seen it twice in almost 30 years. So we wanted to give you the option. So if you still want to put a 47mm filter in, you can do so. But otherwise, you're kind of carrying the cost of that for all of the sites you don't really find it useful. You can also put a long life filter in it now, which is a new thing for us. For the ambient folks, you can barely make it out of this little thing there. That's a filter that has a 6-month changeout, and it's a 0.01 micron cut point. And a lot of reliability for analyzers is something that's not a factor for y'all, because you all do use really high quality sample conditioning before it hits our instruments, right? In the ambient world, that's not the case. So the biggest reliability issues for them, other than component failures, is getting debris on the optics. So they use like a 5 micron filter or a 1 micron. This is a 0.01 micron, which means that new CAPS instrument of ours, I've seen some of those run 8 or 9 years in the field without needing mirror cleaning. Kind of unheard of. So to your question, you can specify either of those options still. The difference is it'll be on this back fold down panel rather than on our T-Series where we had a front fold down. Well, this one, in ours, it shouldn't be that way because our sample always comes in from the back panel and goes directly to that filter. That's the first wetted surface it hits in our instrument, even though it's at the opposite side of the chassis. In this case, we just changed the position of the filter, if that makes sense. It can. There's not commonality across all of it yet, just because our manufacturing engineers haven't fully done the BOMs, bill of materials, sorry. But for all of the low-level instruments, the EPA gave approval to it, which for us matters for that ambient marketplace, but that means it makes sense to do the tooling for others. Anything else? NumaView. This was one of the smartest things we did with the T-Series, is not making everyone start using NumaView up front, because you don't fully ring out a new interface until you've had it in the field with a lot of users. And if you roll it out at the same time you roll out new hardware on the analyzer side of things, you can sometimes chase a lot of intermittent problems or try and diagnose things that are firmware as opposed to hardware. So we rolled out the T-Series and had it fully mature, had virtually, well, very few instrument issues. Then about 5 years after we rolled it out, we really started pressing on the NumaView. And the reason we did that is we have well over 100, no, it's actually over 200 firmware sets of our legacy coding. So if you have to maintain all of those plus all of the new NumaView sets, you've really increased your coding load. So at some point in time, you really want to transition. But the good news is on the N series, we won't be transitioning the user interface. And the NumaView is getting very mature now. One of the things I like best about this is on the home screen, you can select 3 variables that you use most frequently, rather than having to arrow down through menus like you always used to have to do on our legacy instruments. It does have real-time graphs, which I initially, when we were talking about doing that, I thought it was maybe a little bit unnecessary. But when we're working on instruments in the lab, we use this stuff all the time. You could pull a few parameters up and run it. And for something like an instrument that went wonky during the night in a CEMS shelter, it's really nice, because if you keep the high-res DAS running in the background of your instrument, you can pull up variables so you can go, what happened at 2 o'clock in the morning that we failed Cal at 3, you know? You can look and go, oh, we had a power interrupt, because there went the flow, you know, there went the high voltage power supply, and then bam, bam, up and down. That would have saved me like 2 trips to Columbia last decade, because we were sure we had intermittent instrument problems. What we had was a municipal bus that pulled up and idled next to a shelter every hour for 5 minutes. I took 2 trips to South America to try and figure that out. If I'd had this, I could have just gone, well, what happened during that hour? And I would have seen it spike like that, and I would have seen the raw count go up, and the flow would have looked good. And I would have said, it's an application thing. So whether you use it or not initially, I think you'll like that. This is another thing I like, where on our older instruments, you had all of the VARs, as we call them, or variables on a Knox box. How many are there, Ray? Over 100? And you have to know them all or have them written down to go, oh, and I can jump to 88. I remember doing it, jumping to 88. And I thought I was so sophisticated because I'm not having to arrow, arrow, arrow. Well, here you can just choose the ones you use most frequently and put them on this dashboard, as we call it. So usually an instrument will come, it'll have 2 pages of these, 12 to a page, but you can configure that and just have the stuff that you think is most useful or your text do, and you can standardize it by, repeating the config when you get new instruments for all of your gear. The graphical, I mentioned that'll start populating when you hit on that little icon in the corner. If you're pulling out of your DAS, you can just select a timeline, like my other example. Like I want to see an hour during the middle of the night when this thing started going crackers. I want that, and you can have multiple variables that you have it tossed on the same graph. Then it will populate right away. This one will just start populating. If it's right now, I'm looking at flow, it'll start populating as it goes across. The interfaces, anytime you get an alert on it, it will just give you the little icon like usual, but it will also give you a description of what's going on. What's really nice about this is, have you ever gone out to an instrument and it was doing something or something's wrong and someone helpfully cleared the alerts? You go out and say, well, what was the alarm? What was the alert? And go, well, I don't know, I cleared it. Well, that's very helpful. She's saying, I gotta go. I'm going. She's strict. In this case, there's an alerts log. So anything since we first fired up this instrument will be retained unless you go through and wipe it. So you can see the first time this got fired up out at San Diego and put on the test track. Same thing with this. Oops, went too fast there. You can set up your own warnings, either based on a delta. If you just want to know anytime you see a concentration change beyond this magnitude in this period of time, you can set it up. You can set up reminders in here. Just say, hey, I want to make sure somebody checks on that source next time they pull that thing apart, and set it for quarterly. Yeah. Right. That's fully a CiSCO question, based on what you all and they decide you need. We've got all the flavors of this internal to the instrument. And honestly, when I'm talking about this stuff, all of us are aware that either for security concerns or just how people routinely like to use stuff, a lot of folks won't have the latitude to use this unless they're at the face of the instrument, right? Because they don't allow a remote digital interaction with the instrument. So no, pose that question to them. Let's see. Same thing we were talking about earlier. You can pull out multiple variables and use them for diagnostics. And USB, that's how you do the updates on firmware if you choose. You can contact us or CiSCO, ask for a firmware update. We'll send you a link. You can drop it on jump drive, go to the instrument, and it'll recognize you got a update on that jump drive, ask if you want to download it, and you acknowledge. That's the N series. Any questions on that? Yeah. Short answer is hell no, because no, it'd be disingenuous there as they were not always a work in progress with any analyzer. But what I was telling you earlier is NumaView was introduced and developed way back when we were working on our T-series, which is still our primary generation we're shipping. And we had a lot of time to work with it, but it's not till a lot of people in the field are using it that you really wring this stuff out, like what these guys talked about with the memory usage. Right now, I meant what I said. This is a very mature interface right now. I'd feel totally comfortable. When I was in here talking to CiSCO 4 or 5 years ago, it was still early enough days transitioning to it that that wasn't the case. You would have seen more gotchas and bugs. But no, I'd feel very comfortable telling you that. Yeah. I don't know a current percent, but part of that's because of lead time concerns with those ICs. So they've got a little bit longer lead. We're not way different from standard leads right now with the T-series. But you know, I can say that off the seat of my pants, the T-series are still our primary generation. Part of that though is if you tell someone that yeah, you can get them a box in 45 to 60 days, I'm pretty excited about that and aren't interested in changing. What was that? Well, it like I said, that's more fortuitous than good planning on our part. Because I guarantee 2.5 years ago, I probably should have seen this coming. Not that's my role with us, but should have seen the supply chain stuff coming, shouldn't we? And it would make sense that people couldn't be home in their robes and have inventories at a peak level. But okay, so these are the T-series that are still available, all of the models that you've been aware of. And in this case, we do have that 802, which has the paramagnetic O2, as well as an NDIR CO2 for 0 to 20%. These are the most common you've seen. Just a quick mention, if you haven't seen this, T300U is actually what we call a trace instrument. And oddly enough, we built this for the ambient folks for the EPA, but more people use it in the stack world than anywhere. We've got hundreds of them on stacks because they have very, very low drift characteristics. And some folks that had very restrictive permits found that the best way to get there. So it's just kind of, if you run into one of those at a facility you're working with, bear in mind that you want to interact with them completely different than a T300. Temperature is a big concern, stability is a big concern. So if you fire up a T300U, literally you're going to let it sit for 2 days before you try and show it any gas. Much different from a standard T300 or other GFC IR. NOx. Every time I've talked to primarily lay people, but you'd be amazed how many people in the industry, the most common question I get is, how do you determine what converter goes in them? And you might think that's unlikely, but I had a guy call me up 6 months ago, and his plant will be unnamed, but he was furious because he said he had a stack tester in, and damn it, his chemi was showing a CE of 44%. And I said, well, that's a problem. I thought, wow, we must have moly issues I'm not aware of. I said, well, how old is the instrument? Well, 4.5 years. Well, has the moly ever been changed? No. Should it be? And that's a guy that manages CEMS at multiple stack sites. So a lot of people just really aren't aware of how you and CiSCO specify these. So our moly just, yeah. Yeah. But we have the, yeah, we have the technology. It's kind of like when I guess Bob was talking about New Jersey or California, when there's a driver for it, we have the technology to do that. It's just simply, well, we wouldn't even, no, we wouldn't actually even need to do that. We build a Chemi now that's a T200 with that blue LED converter. It's simply that it hasn't had any demand at all from the CEMS world. And unless it does, you don't go through and do the characterization and the method 7E stuff. That's what I'm saying. We have an instrument right now that's a T200. And instead of a MOLLE in it, it's got that blue LED. Between the two, you could buy one now. No, because there's been no driver for that. But if, for example, someone said, we really want to do that, that would be very straightforward. Because it's different firmware. Okay, so the chemiluminescent process is virtually identical, valving and all that stuff. But with that LED converter, you've got a whole different approach as far as how you're handling the CE, et cetera. You do a 2-point cal. That answer it? Yeah. Well, I'll be around after this. I'm letting her down because I can see her eyes keep going bigger. I'll catch you up on this one. Okay. So anyway, our MOLLE, just important to note, ours is 315. That's not the same for all MOLLEs. I believe you use 350, Pete. And for one other manufacturer, I know it's 370. So you want to be careful on that because you can change set points. For ours, it's 315. That's been determined to be optimal for selective conversion. And typically, like it says here, the hotter the combustion process, the more NO2 you'll get, which is the determinant of what's going to be the best converter for the application. So if it's a straight extractive system and the total NOx is less than 10 ppm and the NO2 less than 5, our basic T200, which is a 0 to 20 ppm instrument with a molybdenum converter, is going to be a good choice. If it's greater than 5 ppm, less than 100 ppm, we typically will recommend the T200M, T200H. And that's what CiSCO does in their sleep is, from experience, know what's going to be the best application for your permit. If you've got higher level, it's a pretty linear calculation on lifetime for these. If you can tolerate a lower converter efficiency, you can go to the stainless steel, and it's a high temp converter. Lifetime is significantly longer. You can convert what a MOLLE is going to be based on the ppm hours you're going to show it of NO2. You can determine, that's why that guy's question is, what the hell, need to replace a MOLLE? It's like, that's something that somebody at some point selling him a system or building a system for him should have told him. Now, this is something you need to periodically do and budget to replace. Just a quick summary of that. This is something that we put together for every instrument we build. A lot of folks will get our instruments, maybe if they've been through FedEx and UPS and they arrive with some problem or something changed, they go, well, Jesus, didn't you ever start this thing up? It only takes us about 4 hours. If you've been out to our plant, it takes us about 4 hours to build an instrument. It takes us a week to 2 weeks to satisfactorily test an instrument. We put them on dedicated racks. We go with extended zeros, spans, linearities. we look at it as closely as we can so we can send it out by serial number. It'll even tell you who built it. Nockwin is a guy I've worked with for a long, long time. He's our infrared lead. And this will tell you not just what the control limits are that they're looking for it to meet, but what it actually performed at on that individual instrument. That's really useful. And if you have an instrument out there that you don't have that, you can always contact us, give us a serial number, or contact CiSCO, give them a serial number. We can tell you not only how we built that instrument, but how it tested as it left, which is pretty good for, pretty useful as a baseline if things aren't going well. This is just an internal health report that you can generate with that NumaView interface. Quick mention, we do have a web store. That can be a lot easier if you're able to use a credit card. Get your folks to just call in. Lead time is usually quicker than if you talk with our inside sales folks. What have lead times been like on most of the spares? Any issues? Well, good. Glad to hear it hasn't been hugely problematic. This is just our tech support. We're here to work with whoever the end user is, as well as the integrators. So if there's something we can be useful with, give us a call. If you have a hard time reaching anyone, you can always give me a call. I'll leave some of my cards up there on the table. But thanks for using our gear if you have. Don't hesitate to let us know if it's not working the way you need it to either. So that's it.
We've done that. Whenever we talk to you, we can bypass some of the.
I don't remember any of that, Ray.
Get the job. I'll say.
Any other questions? We'll catch you on the. Hey, thank you very much.